So my name is Klaus Jorgensen. I'm a program manager in our Windows File Server team. I'm here today, this morning, to talk to you about what we call cluster client failover, as well as scale out. So how many here have already heard about cluster client failover? Good. How many here is aware of scale out? All right. With me, I have David and Dia, who are very instrumental in doing the work in Windows on these particular two areas. So if there are any questions that goes into the deep technical matters, they can help answer questions here as well. So cluster client failover, in order to understand why that made sense to do, we want to talk about what is the problem that it's trying to solve, or what it is problem that it's solving. So consider a configuration where I have, for example, a SQL Server deployment running in a cluster configuration, and I have a SQL Server instance that is running on one of the nodes, and it's accessing a backend file server. So this really matters when these file shares are enabled for continuous availability. When the application fails over to a different node and attempts to recover its state, the application will attempt to open the files that it had before the failure, right? So I'm running over here on this node. I have some files opened on this remote file server. This node disappears. Let's say a power failure, and the application is started over here, and naturally that application has a configuration about what files it needs to open. It'll attempt to come back and open those files. The problem is due to some of the semantics in file shares with continuous availability is that because of the handle fencing that we're doing, that needs to happen, then that open will actually fail with a sharing violation, which is, of course, not the desired behavior, because in that case, the application will fail to start, and we will need administrative intervention to recover from that state, which is not desired. So the goal that cluster client failover is intended to solve is to allow these server apps to reopen their files after a failure with no sharing violation or any delay. That make sense? So it's applicable for server apps that can recover from unplanned failures by moving to a different SMB3 client computer. It is part of the documentation in the protocol specification that I'm assuming you all have read multiple times. So let's talk about the app instance ID on Windows. So in order to solve this problem, the concept of an application instance ID is introduced. So the application instance ID is supplied by the app, right? So in this example I used before, it would be supplied by SQL Server. Now there are two modes in Windows where you can specify this. There is user mode callers, so this is an application like SQL that is running in user mode, or a kernel mode caller if you're an application that runs in kernel mode on Windows. So in user mode callers can do a one-time process registration through the user mode API, which is called register app instance, that is below here. And it takes a couple of parameters. It takes the process handle, the ID supplied by the application, and whether any child objects or any spawn processes off of this application needs to do the same thing. Because this process could spawn multiple threads and other processes that would need to inherit this particular app instance ID. On Windows, there is a kernel mode filter driver that implements the process registration. So what it does is once the application has registered, when the application is calling to open, then the filter will actually attach the application instance ID that was sent by the application as the ECP when that goes over the wire to the remote computer. So from the remote computer's point of view, all you see is, as in the protocol doc, is that ECP parameter that's specified comes with this application instance. And this particular SMB2 create app instance ID is described in section 2.13.2.13. If you've had any more details about that. Does that make sense? Any questions on this? Oh, this is going great. Now, on the server side, we need to associate this unique ID, we call it the app instance ID, with all the opens that are belonging to that instance of the server app. Right? So basically, all the files that are open from, in our example, SQL Server, its database files, its system database files, etc., would have this particular app instance ID associated with them. And then in section 3.3.5.9.13 describes the processing rules for SMB3 server. There are two here I want to highlight. Is that one, the application needs to have at least generic read to the files. So that's one angle to ensure that we don't have other clients that don't really have access to it, to just bombard the system with application instance IDs and shoot down other clients, which is of course not the desired behavior. And then that the actual instance ID is matching with the previous instance of the application. And what can you infer from this? Basically that the app instance, when it's running on one node, and when the application starts up on the second computer, this app instance ID needs to be exactly the same app instance ID. So the application will need some sort of mechanism for this application instance ID to traverse when it recovers on other nodes. And that is left up to the application on how it wants to deal with that information, how it wants to deal with that scenario. Now, if we want to take a look at the applications that I'm aware of that supports cluster kind failover and the app instance ID, there is Windows Server 2012 Hyper-V. So Hyper-V supports basically on each VM, it has an application instance ID. And for your information, it uses, every VM has a GUID, so that it uses that VM GUID, and that stays constant as the VM is traversing a cluster. Let's say you do a live migration of a Hyper-V VM, then it stays constant. But that's the case, live migration is a planned move, everything's shut down cleanly, so we're actually not invoking cluster kind failover in that scenario, only in the case where, let's say, a Hyper-V node actually, let's say, suffers a power loss, and the VMs are started up elsewhere. Would this actually be invoked? SQL Server 2012 does not support this from the bits that was released back in, I think it was March. But they are working on implementation that supports this. I cannot make any announcements, but it should be shortly. And then the last piece is that for Windows Server 2012 specifically, when you have a cluster configuration, there is what we call a generic application cluster resource, which effectively is a way to take any, almost, I wouldn't say arbitrary app, but an application, and that doesn't really have integrated support for a Windows cluster. You can actually put it what we call a generic application cluster resource. And in that case, that resource will actually do the registration on behalf of the application if you put it in such a group. And what it does is it basically takes the GUID of the cluster resource group and attaches it to the application on the process. So it starts the application in pause, gets the process ID, does the registration, and then it kicks off the application. Now, this can be done for any application on any platform. Yes?
It looks like it's sent to a clear context, this app instance. So it looks like the app instance is sent to a clear context.
Uh-huh.
Is it sent to for every client? Every file open?
Yes.
Could you repeat the question again?
Yeah, sorry. So the question is, it looks like this is the app instance ID is sent on the create context, and it will be sent on every create.
But the value doesn't change. It's like a same process ID most of the time.
Yes, well, so if you're a user mode application, the user mode application does the registration on startup before it opens any file handles whatsoever. Then when the application then subsequently opens files, it doesn't do anything. On Windows, the filter that sits lower in the stack would actually say, so, oh, this is the process with this process ID. It did a previous registration, and I'm now going to attach this ID that it registered with me on behalf of the application with every crate that is sent over the wire. That make sense?
Yeah, makes sense. The only thing that is same information is going again and again.
If you open to a lot of crates, yes, we will attach it every time. But we need to have it on each file, because each file needs to be, when you have the power loss and you open all these files on the other node, then we need to make sure that you can actually invalidate those on the file server backend, so we can actually get through to those files again. Any other questions around cluster client failover? All right, it's all clear.
You tell this. Okay. So you do have to give the application ID to the SMB server, right? Where does that go?
So the application ID is sent over the wire as part of the ECP, and then it's up to the SMB3 or server implementation to store the relationship effectively between the file handler and.
You said ECP. I'm sorry. Which request? What message? It's create context. Okay.
It's called create app instance ID, and
Okay.
it's one of the 3 new create contexts, or however many there are.
Sorry, it's this one.
Well, no,
Right?
that guy, right.
Okay.
The API is the local way that the application registers itself. And every time that's registered, the creates go out with that extra create context.
And that context is sent in which command?
Every create.
Create? Create, yeah, okay. That's what I thought. Okay, good. Thanks.
Any other questions?
Chris, that behavior is flagged by one of the server capability bits. When that capability bit goes true, the client starts being eligible to send these guys. You can see it at the top.
Okay.
Poke around 2 or 3 spots.
I just wanted to know where to look.
SMB2, it's all there.
All right. So shifting gears to topic number 2, scale out. So scale out file server. The idea here is that basically being able to expose the same share and the same share content through multiple physical computers, or for that matter, virtual computers, to clients at the same time. Effectively creating what you could call file shares that are active across numerous machines. And why would you want to do that? To increase the bandwidth to the storage, right? Because without this, the bandwidth would be constrained to whatever is possible by any one of these nodes. Let's say you have a configuration where you have a client and you have a number of servers, then the bandwidth will be constrained to whatever that one server can do. That make sense? All right. So on the server side, and this, by the way, is the same information that David and Matthew was talking about at SDC 2011. So if you were there, you would have seen these lines before. The file system semantics must be coherent. No surprise there. The persistent portion of the file ID must be unique across the cluster, right? session invalidation must span nodes to locate and disconnect sessions and reconnect. So effectively, if I have a client that is connecting through one of the nodes and I lose that connection and then I reconnect to another node, then there must be a mechanism to be able to go and disconnect that session on the back end. Server returns the SMB2 share cap scale out in the tree connect response to inform the client on the capability that it can actually connect to multiple of these servers. Any questions on the server requirements?
These are not shared across nodes. Lease keys are not shared across nodes. I'm just struggling with that.
Can you help me with that one, David? The last bullet.
It's associated with the idea that the clients are expected to only connect to a single node. So if you look at what lease break semantics are, if the client breaks out of that and tries to connect to two different nodes and uses the lease keys across both of them, the break semantics are different because the two servers aren't talking to each other to conform to the overall break semantics. Now, if your file system supports that across your clustered ones where essentially your leases are cross-node, then the fact that you do support it isn't a violation. This is more a Windows behavior that says we don't support it. Does that make sense?
So let me see if I get this straight. A client is connected to one scale-out node, requests a lease, has a lease. The idea you're saying is if the client broke the rules and connected to a second node in the scale-out scenario and tried to obtain a lease on the same file, they couldn't use the same lease because it doesn't transfer, and using a different lease would actually break their op lock, their lease, on the first node. Is that what I'm hearing?
More specifically, if they use the same key, even though they're using the same key for the second node, it will cause lease breaks with their usage of the first key on the first node, because on the back end, the object store will treat keys from different nodes as being different keys. So that's what ends up happening.
All right. So I'm just trying to follow this through, and I appreciate your patience here. But what you did say, well, first of all, it's kind of a violation to use two servers in this environment. Is that one of the things I heard?
Yes.
So I'm getting a yes on that. Okay. Currently, right? Okay. And I won't. Yeah. But if the backend file store can transfer leases between nodes in the cluster, then we could still use that capability. Is that something else I heard from you?
So what I'm going to say is there isn't prescriptive client behavior here, right? If you wrote a client that's aware of these limitations, you could easily have a client that connects to multiple nodes and just opens a different file per node, because then you don't have the lease break conflicts going on, right? But this isn't like PNFS style stuff where you're going to open the same file across all nodes and splay out your reads, although you could do that as well, but then you couldn't use leasing on the implementation here, right? So I guess what I'm saying is it's not a requirement per se that no one can implement a client that connects to multiple nodes, but this is supposed to describe from the protocol on the server level behavior, what's going to happen and what you'd have to work around if you want to do it. And then there's also another question for beer or lunch that says, is it really interesting to have them spray out? But we can talk about that later. Okay. Does that answer?
It's getting close. There's a lot to learn here, so thank you.
So any other questions on server requirements that David can help me out with? So a client, the client will prefer the current node on a reconnect. So if I get a disconnect, I'll connect back to the same server, but I must be able to fail to any of the nodes in the scale-out configuration. And since the scale-out configuration may change over time, and the client information, given that we are, as you saw in the first slide, we're using DNS, that configuration that the client knows may not be the same as the actual state on the back end. So the client must be able to recover from that. And if there is a node that is, for example, evicted from that scale-out configuration, then it will treat that as an unsuccessful auth, and then it should retry some of the other nodes. And back to the conversation we just had, a single Windows client will operate against a single node at a time. So what does that mean? Well, it means exactly that, and it means that scale-out configurations are probably most useful when the ratio of clients to server is at a decent ratio. Like I have more clients than I have servers. Some of the scenarios you can think of is that you have X number of, let's say, Hyper-V servers, 32, 64, and 2 to 4 scale-up nodes, where you would have a fairly decent distribution of the Hyper-V computers across the backend file servers. So, with the fact that all these scale-out computers are registered in DNS with the name that we're connecting to, then most DNS implementation by default will round robin the response to the DNS request coming in from the client. As far as I'm aware, DNS sorting is usually sorts IPv6 and IPv4 addresses separately, and they're concatenated then with IPv6 at the top. If we take a look at 2 subsequent DNS client requests for this particular name called SMB3, we can see from the output here that in the first request, let's just look at the IPv4s because they're a little simpler to actually look at. The return request is 10, 10, 22, 17, 108, 148, and a later request returns a different ordering of the same set of IPs, which will basically, as the client computers are coming into the cluster for the first time, they do the DNS lookup on the name, and then they will presumably attempt to connect to the first one at first. So, but the Windows SMB3 client is resilient to unavailable IPs. So what does that mean? The logic here is that the client will attempt to connect to the first IP address in this list. After 1 second, the client will, assuming that there's no response, after 1 second, the client will connect in parallel to the next 7 IPs. And if any of the previous attempts fail, the client will attempt to connect to the next IP. So effectively, we will have up to 8 outstanding requests at any point in time. The client will continue to do this until it reaches the end of the list. Basically, all IP addresses have been exhausted. And it will proceed with the first server to respond, which of course in most cases will be the first IP that it goes to. But let's say, for example, that server had become unavailable due to servicing or power loss, etc. They'll just go through the list.
So, so it attempts to contact the
So like on a reconnect, it tends to it tries the address that it had before first, and then it connects to the others in parallel, or the next 7 in parallel, and then just grabs whichever one responds first.
Yes.
Is it? Okay.
But if it was already connected, they'll try to go back to the original one first if it had a disconnect.
That's similar to existing Windows behavior, where if it has multiple choices. Existing Windows behavior just for an ordinary share. If it has multiple choices, it'll try one, give it a head start, and then try the others. And the first one to respond wins.
Any other questions? So, similar to the previous slide, connects to one and only one cluster node for a given scale-out file server. But the key here is that if you can actually have a set of scale-out nodes that provides multiple names, then each name will be treated as a different set of scale-out nodes. So if I connect to 2 different names, I could actually end up on 2 different computers in the scale-out backend, even though I can actually sometimes get to the same data.
So the host name you're connected to matters, even if they resolve the same address.
Yeah, so give you an example. So specifically in the Windows implementation, any of these different configurations of the scale-out file servers on the server backend is all seeing the same storage, regardless of how many names you add to it, right? Now, if I connect to one name and then subsequently connect to another name, because there are different DNS names, I could end up with 2 separate DNS lookups and therefore connect to 2 different machines. But effectively on the back end, I'll see the same view, assuming I create the same shares under both names.
Does the client cache on the first connect? Does it cache the list? When it, we'll assume he connects, he gets a failover, he's going to try the same one he tried before, but has he already cached that list, or does he have to do another lookup?
So the question is, does the DNS lookup get cached on the client? So that is really below SMB, but yes, the Windows DNS client will cache the information. I believe the default is for 30 minutes. Is that correct? But anyway, if it will cache the information and it'll adhere to whatever is the time to live on those cache entries that is specified by the DNS server. Does that make sense? And that is why, if you come back to DNS, conversions can take time because of DNS forwarders and secondaries, etc., which is again goes back to why the client needs to be resilient to DNS not necessarily be completely in sync with what nodes are up and down, because trying to force that relationship is not going to work. Any other questions to this? All right, good. So that effectively was cluster client failover as well as scale out. I do have a third topic that we can discuss if there is interest in it, because we've got the Dia and David here around witness. If there's any concerns or questions around service witness protocol.
There will be.
There will be.
When we get there.
Are you all familiar in the concept of what it does? Okay. I see silence. Does that mean yes or no? Yes? All right. Well, in that case, I'm not going to go through it unless... Okay. Well, that concludes my talk. And I'll stick around, and I believe Dia and David will stick around too for a few minutes. If you have any questions that pops up in your mind after you have digested this. Thank you.